Hello, Assalamualaikum warahmatullahi wabarakatuh. Alright, my name is Muhammad Ashraf bin Abu Qasim. Alright, today I want to present my topic, my final year project, which is optimizing of a spiral channel parameter for aluminum alloy non-retic brand using Taguchi method. This is my supervisor, which is TS Dr. Hanizam bin Hashim. Alright, I'm from Faculty Mechanical and Manufacturing Engineering Technology. Alright, this is introduction. Right, introduction. The spiral channel technique is the oncoming semi-solid process, which is the objective is to optimize the parameter of a spiral channel of mold casting and analyze using Taguchi method, which is the new method of casting, mold casting, which is we use spiral channel. Before this, the researcher of previous journal they use the cooling slope and mechanical steering. Alright, the next is my objective. The first one is to determine the process parameter that will affect the microstructure transformation, and the second one is to optimize process parameter using Taguchi method. The last one to determine the size and the spherical factor of non-dendritic microstructure using microscope. Alright, we can to read the data by using optical microscopy, the grain size and the spherical factor. These two variable is very important that we gonna gain the outcome with the precise result. Alright, and the next one is a problem statement. The first one is the spiral channel is a new mechanism. As I told you just now, spiral channel is a new mechanism for developing the best non-dendritic microstructure. But there is no data yet. The casting process, non-dendritic met a high attention to produce in casting process. And the second one is optimizing Taguchi for more casting process of semi-solid aluminum alloy. We select Taguchi method because it is simple and robust. Right, for the scope project, we'll be focusing on the material chosen for mold casting process, which is we use aluminum alloy. Concept will be regenerate because, of course, we use a spiral channel. Later, I will show you the picture of the spiral channel. Right, literature review. Non-dendritic, the shape and size of the particulate change irreversibly over time, which separate semi-solid metal slurries from other suspension. Right, Taguchi method, robust design is an engineering methodology for producing high quality development and manufacturing obtaining product. Because Taguchi method is where we used to analyze to compare which is the significant, which parameter affect the most when the result come. I mean the graph, the mean graph, the signal noise, and the mean standard deviation and so on. Alright. Alright. Methodology. Methodology is a process of flowchart. The first thing, material selection. We use the aluminum alloy. The second one is we design and develop spiral channel. We fabricate the spiral channel. We welding, fabricate, bending, and we use water jet to make a spiral channel. And after that, we assemble, welding, and the next is a mold casting process. We go to the FKP lab, and after the final product of the mold casting, we cut into 10 pieces with size 1 cm. This, alright, the quality of specimen. Alright, this specimen we polish. We go to metallography lab, material lab. We polish using sandpaper first. Then the next step is we use the polishing pad, 6 micron, 1 micron, and 3 micron, and we etching and direct go to the casting lab to use the optical microscopy. So we can read the data analyze the data, we get the area, which is the grain size, the roundness, spherical vector. We managed to get more data, but we extract only 30 data in each of these specimen, as you can see. All right. As you can see, the next one is this is the final product of our spiral channel. As you can see, on the right side, it looks like spring potato. We managed to spray with black color on the casing and the cone. So we put the the melted steel inside this through the spiral channel and go through the mold. Right, and the next one is non-dendritic microstructure. Actually, this is the result of our non-dendritic microstructure that we took from this specimen. Alright, the shape and the size of particle change irreversibly over time, the one I explained before. And I would like to explain the design of the experiment, right? DOE. Right. After we cut the product into 10 pieces with size 1 cm, polishing with sandpaper, alright, and etching direct looking into the optical microscopy, we can to read the data of the grain size and the spherical vector. As you can see, we have the 8 trial, 8 specimen, 3 parameter, pouring angle, mold temperature, and spiral length. Sorry. So these two variable, grain size and spherical vector. This one is we took the first attempt of spiral channel, the first one, which is uh, 32 cm, and pouring angle 90 degrees, and mold temperature 700 degrees Celsius. Right. The next one is the result and discussion. As you can see, the main effect plot from means. Right, the spiral length affect the most because the longer the spiral, the length of the spiral, the less the flow rate when the mold go through the spiral channel. Like the factor with the biggest delta value 1, as you can see in this study, is spiral length, which is placed first, followed by pouring temperature and pouring angle. The spiral length is most significant influencing parameter to the this experiment, because that we know the longer the less flow rate it will be to gain a perfect result at the non-dendritic microstructure. Right. The last one is conclusion. This project has discussed an application of Taguchi method for study the effect of spiral channel. Casting process parameter has resulted the combination of spiral channel parameter, pouring temperature 700 degrees, and pouring angle is 90 degree, and the spiral length is 320 millimeter. We want to conclude this finding result experiment for this project starting when we achieve the main objective of this project, which is to determine the process of parameter will affect the microstructure transformation. Second, determine the grain size and the spherical factor of the non-dendritic microstructure. And lastly, for optimize parameter using Taguchi method, because we want the perfect result to compare which one is a more significant level. Alright.